Hi everyone, today let's solve the problem number 143, reorder list, right? Reorder list. So what the question states here, we are given a singly linked list. You can clearly see here, just give me a second here. This one. We have been given a singly linked list here. The list can be represented as like this they have given here. So L0, L1, Ln minus 1, Ln. So this one, 1, 2, 3, 4. So we have to reorder the list to be the following form. L0 equals ln minus L1, ln minus 1, this one, to the L2. Same thing goes on here, right? So this would be basically 1, 4, this one, 1, 4, then 2, 3. If the elements were more, we would carry on with the same operations, right? So this is what we need to do accordingly with the question we have. So suppose if we have 1, 2, 3, 4, 5, 6. So here we have to go with 1, 6, 2, 5, 3, 4. That's what they are asking us to do in the question, right? I hope the question part is completely clear. Same goes with here. See here, 1, 2, 3, 4, 5. So here this 1, 5, and this one 2 remains constant here. 2 remains constant. We have to find the mid, and 2 remains constant here. In this case, 1, 5, this becomes 2, 4, 2, 4, and this one 3. We have to get this one. You would have thought that we would be getting 1, 5, 2, 4, and this one. Sorry, what do you call? 1, 5, 2, 4, and 3. Right. So if you would have guessed it, you would have guessed that one right. See here. Nothing but so here 1, 5, 2, 4, this one 3. Right? So 1, 5, 2, 4, 3 at the end basically. So this will be 1, 5, 2, 4, 3. In this order we have to write the code. So that's we have to write the algorithm. That's what they have stated here, right? So we have to reorder the linked list accordingly with the given condition in the question. So I hope the question part is completely clear, easy to understand. Let's do one thing. Let's move on with the approach. So right, so let's move on with the approach. Let's discuss the approach followed by the complexities, and then let's write the code. Let's come to the approach part here. Let's consider the same first example here. We have 1, 2, 3, 4, and we have to reorder in the accordingly with the given conditions, right? So here in this case we have the example, the first example we are considering this one. So we will consider the list in this way: 1, 2, 3, 4. First step, what we'll do, first step here is they have asked us to reorder the list, right? So we will be making use of the linked list data structure basically, and the operations that the linked list provides, data structure provides basically the operations that the linked list provides in Java, as we are making use of the programming language Java, right? So operations that linked list provides basically in Java. So we'll be making use of the linked list data structure here. Um, in this case, first step is we have to find the middle. We will find the middle. So we will be making use of the slow and fast pointer. We'll be making use of slow as well as the fast pointer. Two pointers we'll be making use of here, slow and fast, right? So here in this case, first we will find the middle. So how many number of elements we have? 4. 4 by 2. So this will be 2. 2 will be the mid. 2 will be the mid here in this case, right? So mid we got here as 2, and now we have to split as 1, 2, and 3, 4. So we have to split into 2. We have got the mid 2, so we will split this one into 2 parts. This will be, see here, 1 and 2 will be one part, and 3 and 4 will be one part. 1 and 2 will be one part, and 3 and 4 will be one part. So this is one part, 1 and 2, and 3 and 4 will be another part. 3 and 4 will be another part. I hope this part is completely clear. Now we need to reverse the second half. After finding the mid and segregating this one into two parts, then what we will do, the right part is there, right? The second part, this one we will reverse the numbers. We will reverse the numbers. Basically what it happens now, now the elements 1 and 2 remain same, and when we reverse 3 and 4, it will be 4 and 3. It will be 4 and 3 instead of 3 and 4. When we reverse the numbers, this will be 4 and 3, right? After this step, the final step, what we'll do, we are done with the two steps, right? So we are done with the two steps. First one is finding the middle and segregating into two parts. Accordingly, with the mid we will be segregating the mid to two parts. Then after segregating them to two parts, what we'll do, we will this one mid we got two, so we have segregated them into the two parts. Then what we will do, we will uh, what do we call, we will reverse the second half, means from 3 to 4 to 4 to 3. We have reversed the numbers. Then we will merge these two are different right now. We will merge these two, right? First element from the suppose this one is suppose this we considered list 1 and suppose this we considered list 2 for now, just for the example sake. We will merge the first number from the list 1 and the first number from the list 2. So this will be 1 4, and the same thing goes with the second number from the list 1 and second number from the list 2. 1 4 2 and 3. 1 4 2 and 3. So the output that we got here is 1 4 2 and 3. The output that we got here is 1 4 2 and 3, which is equivalent to the output that they have given for the output, this one, example 1. So our approach works absolutely correct. First what we did, we found the middle here. We calculated the middle and we segregated that one based on the middle into two parts here, 1 2 3 4. Next what we did, we reversed the second half, nothing but 3 4 to 4 3. Then after reversing the second half, we merged both lists alternatively. We merged both lists alternatively. That's what we did here. 1 2 4 3. We merged this one, right? So this one 1 4 2 and 3. So the final result that we got here is 1 4 2 3. Accordingly, with the conditions that they have given for the first question, we did the same thing. We successfully reordered the list. So the output that we got was equivalent to the output that they have given for the example 1. I hope the approach part is completely clear. Easy, right? So now as we are done with the approach, let's quickly discuss the complexities. So what would be the time complexity here? The time complexity would be big O of n. The time complexity would be big O of n. Why the time complexity here is big O of n? Because we have to traverse the list to find the middle. First, we have to traverse through the list, or we have to traverse the list basically to find the middle, and then we have to reverse the second half and then merge. Each operation, three operations we are doing here, right? We have to traverse list to find the middle, then we have to reverse the second half, then we have to merge alternate lists basically. These three steps, each list is of the this one, time complexity big of n. So overall time complexity would be big of n in this case. Overall time complexity would be big of n in this case. So what would be the space complexity here? Space complexity would be big of 1. Space complexity would be big of 1. Why it is big of 1 here? Because we are not making, will not be making use of the any extra space. We'll just go with the in place modification. So space complexity would be big of n, big of 1. The time complexity would be big of n, and the space complexity would be big of 1 for the code that we'll be writing in the future. So I hope the complexities part is completely clear. As we are completely familiar with the approach and complexities, we are good to write the code. Let's start writing the code, right? So first step here would be, if head or the this one, uh, if head is null, or the next pointer, this one head dot next is null, then we have to return nothing, right? So then we have to return nothing, or we can just return null. So in this case I can just write that one in that way. Base case, if head equals null, or head dot null, sorry, head dot next, this has to be equals null, then we can return null, or we can just return this one. We can just give return here. This is fine. Let's go with the first step. We have to find, first step was we have to find the middle of the list. To find the middle of the list, let's write the code here. This one will be not lost, man. We are not lost yet. So this one has to be list node, as we are dealing with the linked list. So this one will be slow equals head fast, so sorry, yeah, fast. Let me assign this one to the head. This is fine. We have initialize slow to head and fast to head as well. Slow and fast to head. So we are finding the middle of the list, right? So let's write simple while loop here. While fast not equal to null, and fast dot next not equal to null, and also fast dot next not equal to null. Then what we will do, This one, let me assign the slow to slow dot next. This is based on tortoise and hare algorithm, also known as Floyd's algorithm. We are moving the slow one step and the fast two steps, right? So we'll assign fast to fast dot next. So this is fine. So we are just moving the slow by one here, and we are moving the fast by two steps to find the middle, to find the middle of the list. So we are done with this. Basically, this is you should be knowing when you are solving the linked list. So you have to know the Floyd's algorithm or the tortoise or hare algorithm. So I can just go through this one. The important algorithms playlist by me. I have taught that one in the, we have discussed that one in the JavaScript. The same thing goes with the Java as well, man. It's not a big deal. So you can just go through that one. You'll understand that one even clear, right? So let me come out of this one entirely. So after finding the middle of the list, accordingly with the approach, next step was to find the or to reverse the second half of the list, right? So we have to reverse the second half of the list. Let's write the code for that. So let's quickly write here list node second equals slow dot next. This is fine. So here the next thing is slow dot next equals null. So we are just assigning the next. So we are just cutting off the first half here. So here the line number 11, we are starting off the second half. The next line is we are cutting off this one here, the first half, right? So next, let me do one thing. So again, I have to mention the type here list node previous equals null. So initially previous will be null. Let's write the main code here. So let's go with the while loop. While second should not be null, right? So while second is not equal to null, then what we will do, we have to store the next node, reverse the pointer, move the previous, and we have to move the second finally. These things we have to do. Let's articulate the same thing in the form of code. So let me consider the temporary variable for that. So this will be list node temp equals second dot next, nothing but we are storing the next node here. After storing the next node, we have to reverse the pointer, we have to swap the elements, right? So we are reversing the two numbers, right? So here, that is the reason we have considered the temporary variable. We are swapping over here. So we have to swap the second half, the value that is present in the pointers in the second half, we have to swap them, right? So here in this case, I'll just go with second dot next equals previous. The next step is we have to move the previous, means this will be previous equals to second. Then final step is here, let's assign the second to temp. Let's assign the second to temp. This is fine. Let me come out of this one entirely. Let me format the code one so that this looks good. Yeah, let me come out of this one entirely. So just give me a second here. Yeah, let me come out of this one entirely. So we are done with the second step. We have successfully reversed the second half of the list. After successfully reversing the second half of the list in the third in the approach, what was the third step? Basically, we have to merge the two halves alternatively, right? So if you remember the approach, right? So these were the three steps we went with in the approach. So let's merge two halves here. In this case, I'll just go with list node. So I'll just go with first equals head. This is fine. So let me assign second to previous. This is fine. And here, let me go with the while loop. So this one is second, while second not equal to null. While second not equal to null, what we will do? We have to store the next of the first, means I'll just go with here list node temp1 equals first dot next. This is fine. The next thing is we have to store the next of second as well. So here I'll just go with same thing. Let me copy the same thing and make the necessary, let me paste this one over here and make the necessary changes. Just give me a second here. This one will be temp2 instead of temp1, and this one will be second instead of first. So this will be second instead of first. This is fine. So let me come out of this one entirely. So the next step here would be we have to link the first to second here. We have to link the first to second, right? So to link the first to second, I'll just go with the first dot next equals, let's assign this one to the second. After linking the first to second, we have to link the second to first next, right? So same thing. So here, let me copy or let me type this one. This is fine. This one is same as the previous line. Second dot next to first. So this linked list, man, stupidity. So this one we have to, the final two lines would be, we have to move to next of the first, and also we have to move to next of the second. This I can write in this way. Let me assign the first to temp 1, and let me assign the second to temp 2. Temp 2. So we are done with the code. We are done with the code. Let me format the code once and let me hit the run button. So I hope this works for all the test cases, man. Or I hope this works. Let's see what happened here. Second temp. Oh, I have forgotten semicolon here. Let me give the semicolon here. Let me run this one again. Now this has to work. Let's see. Wrong answer. What we are getting here? Error found cycle in the list node. 1423. Expected 1423, but we have found the cycle. Huh? Just give me a second here. So I did mistake in the line number 29. Basically, I did this one. I typed in a hurry, I think. So this one has to be, we have to assign this one to the temp one, right? So we have to assign the second dot next to the temp one, basically. So I'll just go with second dot next this one to the, assign this one to the temp one. So if I assign that one to the first, that creates loop. Basically output what we'll get for this one is, so this one, so just give me a second here, 1 second. Yeah, this one we have the input 1 2 3 4. So if we assign the second dot next to the first, then this creates a loop every time, 1 4 1 4 1 4 1 4, right? So this will be 1 4, uh 1 4 again, 1 4 1 4. It goes on. This creates a loop basically, which would be wrong. So basically this creates a cycle and it will be a loop. So this is wrong for this one. So we have to assign this one to the temp one basically. So now let me run this code. So this has to work now. Let's see. So yeah, you can clearly see here the sample test cases got passed. Means the code works absolutely correct in this case, right? So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. All the test cases are getting passed. Means the code works absolutely correct in this case, right? The code works absolutely correct in this case. I hope the solution part is completely clear. I hope the solution part is completely clear along with the uh, complexities and the approach, right? For now, this is it. Thanks for watching, guys.